Hello everyone, welcome to our channel, and we have a new circuit here. We have this Metronome 555 timer module. This is the module 555 timer, some header here, speaker, capacitor, trim pot, LED, resistors. So did you hear the ticking sound? That is the metronome using 555 timer. Let us see the circuit here. So this is the circuit diagram of metronome. We have the 555 timer, pin 1 connected to the ground, 2 to the 6, pin 3 output, and the output we have the capacitor, and going to the header, and to the speaker, and to the ground. Pin number 4 is the reset, goes high. Pin number 5, as usual, it's control voltage. I'm using 104. And pin number 6 here is connected the capacitor 470 microfarad, 16 volts. This is the trim pot, 10 kilo ohms trim pot. And this is the RA, 1 kilo ohms, connected to between 8, also 6. This is the power on LED indicator. That is the LED power on indicator with an RD, which is 1 kilo ohms. We have also header here for the input voltage supply, 12 volts here, connected to the header, positive, and another additional input from the header. This one, that's why I use that additional input for my 555 LED flasher here. As you see him, this is the 555 LED flasher. This is 555 metronome. This metronome is used by the musician to count the beat per second while playing a song, a music. So in here we have also the header here. That is the output header, this one. So I connected the speaker into the output header. Also I have this provision for additional output from pin 3, the output pin, connected to the header. So I can connect here additional output. So what's in here is the Pcb layout. So this is the layout of the metronome. As you've seen here, this is the header input. So this is the header input with this circuit, and the output header is here. So speaker is this output header. So in our previous circuit, which is this 555 timer buzzer circuit, let us see that this one is the 555 buzzer circuit. In 555 buzzer circuit, I'm also using the same component here, but difference is this 1 kilo ohms. Instead of 1 kilo ohms, I use this variable trim pot 10K. So that's the difference. And in here, output 3, I use the buzzer in series with the resistor and an LED flasher. So this one, let us And also this one is a regular LED flasher using 555. This one also 555, our previous circuit. That's in the output also is connected in series with the resistor and LED. Just like in the buzzer circuit, I just connect the buzzer in addition to make an LED buzzer circuit. So this one is LED buzzer circuit, that one, and this is the LED flasher. What I'm going to do here is in output 3, I connected this speaker. This speaker is connected in series with the 22 microfarad 16 volts capacitor electrolytic to positive, negative to the ground. So that's the difference between the three. In Metronome, I'm using speaker. In regular LED flasher, I just use this in the output resistor and an LED, making this LED flasher. Also the same components are using here, 1 kilo ohm, 1 kilo ohm, just like in the LED timer buzzer 555. But the difference is only here. I'm connecting a buzzer here. But in our new circuit, instead of the buzzer and LED flasher, I'm using this capacitor in series with the speaker, making this a metronome. We can control the tick-tick sound by adjusting the trim pot. That is now the sound of the metronome. In here, I'm using a header. Unlike in our previous circuit, I don't have header here. This is an old design also here with this LED washer. These are three circuits using 555 timer. LED flasher, metronome, and LED 555 buzzer circuit. So these three are using 555 timer, and as usual I'm just making a new design here with the header at the input voltage supply and the output. I'm using a header here. So that's the new features I did in our new design. Unlike here, there's no header here. Did you see this? The header is in output. I'm using the 12 volts here. The header is this input header. So that is the way how to make a metronome. And the tick-tick sound is controlled by this trim pot. This is the actual circuit diagram. We have this 22 microfarad 16 volts connected in series with the header to the speaker to the ground. Also here 1 kilo ohms 10K trim pot connected to pin 7, pin 8, and capacitor here is for 70 microfarad 16 volts. Also have RD here 1 kilo ohms, LED here. This one is the LED, and this header for the input voltage. That is the new design. Unlike in our previous circuit, it's just as simple as this. This is an LED buzzer circuit. See the buzzer here connected to the pin 3. Pin 4, that's the reset pin, goes high. Pin 5, control voltage. I'm using 104 just to stabilize the circuit. Pin 6, this is the threshold, and pin 2, the trigger pin connected to the threshold, and 7, discharge pin connected to RE and RB 1 kilo ohms. So as you notice here, this two has a fixed RB. 1K here for the LED flasher and 1K here for the buzzer circuit. Unlike here in our metronome, we have this variable trim pot. Okay, thank you for watching the video. Bye bye.